Hello engineers, welcome to the new video of the course, and in this particular video we are going to plot the drain source characteristic of N-channel MOSFET on the Multisim software. Okay, so before plotting that particular graph, I would like to just revise the concept, right, of the drain source characteristic. So if you could see over here very clearly, basically the drain source characteristic is a plot or was a plot between the output voltage versus the output current, that is VDS versus ID, right? What we saw was that when our input voltage, that is VGS, if it is less than the threshold voltage, right, so at that particular time our ID would be straight away 0. Okay, but let's suppose if our input voltage, that is VGS, that is get to source voltage, if it is greater than threshold voltage, as you can clearly see over here, then we were able to obtain this kind of curve or this kind of plot, as you can clearly see over here. So basically in this curve or in this plot, we actually had two different regions, as you can clearly see over here. Just a second. That is the linear region, right? The the curve or the plot that was just before this particular point, that is VDS set, which is also known as overdrive voltage, or which can also be termed as pinch off voltage. Okay, so as I had already mentioned that VDS set is different for different VGS, right? So let me go to that particular graph. Yeah, so as you can see the curve just before this particular point, that is VDS set or pinch off voltage, it is known as what? It is known as linear region or linear curve. Whereas the region just after this particular point, that is after pinch off voltage or after VDS set, this particular curve or this particular area or this particular region, it is known as saturation region. Okay, why? Because I had already explained you this particular concept. As you can see over here, the electrons, the flow of electron becomes constant as the depletion layer increases. Okay, I hope you are able to understand, or you are able to recollect all of these particular points which we had already discussed. Right now we will just focus on plotting this particular graph on the Multisim software. So let me just go to the Multisim software, and you can clearly see that this is my Multisim software, right? We had already understood the basic operation of this particular software in our previous few courses, right? Now let me go to the transistor. As you can see over here, place transistor. Okay, let me select MOSFET N-channel MOSFET, and over here I will select 2N7000. I will go with that particular transistor. If you want, you can go with some another N-channel MOSFET, but since we had actually seen the threshold voltage of this particular transistor, as you can see over here, what is the threshold voltage of this particular transistor? So double click on it, double click on that particular component or on that particular transistor, and go in the edit component in the DB. Click on it and select 2N7000 and just move a little down, and you can clearly see the threshold voltage. It is around 2.5, right, which is precisely it is 2.474, right? Okay, so just remember this particular threshold voltage, because based on this only we are going to plot the curve and we are going to understand that particular curve. Okay, so 2.474, just remember that particular value. Let me just move it somewhere over here. All right, and now let me select the ground and two DC sources. So for that, let me go to the source and let me go to the power sources, and let me select two DC power. Okay, two DC power sources, and let me select one ground. Okay, great. Now I'll just connect all of these particular things, and then we will plot the graph, and I will show you how exactly we can plot the graph in the Multisim software. Okay, so before that, let me just connect, and just connect as I am connecting over here. Okay, just copy and paste what I am doing over here. I will explain you, don't worry about that. Okay, so as you can see, this is my VGS, right, and this is my VDS. I am not connecting any resistor or something like that, because we are directly simulating this particular graph, so no need of connecting resistors and all. Okay, because if you connect resistor, right, so basically we won't get the proper voltage over here across VDS, right? What we are doing over here is that we are actually changing VDS directly, and then we are also changing VGS, and based on that we are actually plotting the curve, that is the output curve or the drain source characteristic curve. Okay, great. So let me go to this particular option, that is simulate, but before that let me just save this particular diagram. All right, I have saved it. Now let me move to this particular option, that is simulate, and just click on analysis and simulation, And as I mentioned that we will be doing all of this particular simulation at a room temperature, that is 27 degrees Celsius, right? It depends. In some book we will get 25, in some book we will get 27 degrees Celsius, but more or less we can assume it to be quite similar. I know there is a good FT amount of difference between 1 degree Celsius, but that's fine. As of now, for simulation purpose, we can assume that these both values they are all more or less similar, right? Then go to the DC sweep. Click on the DC sweep, and now I'll just cancel it because I need to do certain changes over here. Okay, so whenever you are connecting this kind of connections, and if you want to plot a graph, make sure that you give label according to your according to your will. That means what? See over here, the V1 and V2 sounds very confusing, right? What is our input voltage? It is V2, but we all know that for MOSFET our input voltage is VGS. So give the label as VGS only. Give the label as VGS. Great. And since our output voltage is VDS, so give the label as VDS. VDS. Okay. Let me enter it. Great. Now again go to the simulate. Click on analysis and simulation, and over here click on DC sweep. And okay, so now remember one thing over here. See, we have two options, source 1 and source 2. Okay, if you could remember, in case of transfer characteristic curve or in case of transfer characteristic graph, we had only selected source 1. Okay, we had unchecked the source 2, right? But this time we have to check the source 2 as well. We have to click over here on the source 2. We have to use two different sources. Okay, but the point to notice over here is that where I should enter VGS and where I should enter VDS, because we want the output curve or the output graph between VDS and ID, right? And VGS is acting like a third parameter which is responsible to generate that particular curve. Okay, so should I keep VGS over here and VDS over here, or should I keep VDS over here and VGS over here? So remember this particular point as far as multisim is concerned. And since, see, we want to plot a graph between ID and VDS, so you always select that parameter which you want to plot over here in the source 1. So in source 1 we should select VDS. Okay, since we are dealing with the drain source characteristic, so that's why we are selecting VDS. Now let's suppose if we want to select let's suppose if we are plotting the transfer characteristic curve. Okay, so we all know during transfer characteristic VDS is of no use, right? We are not focusing that much on VDS, rather our majority of the focus is on VGS, right? So over here we we keep VGS over here, right? But as I mentioned, since we are plotting the drain source characteristic curve, so it is a plot between ID versus VDS. So in source 1 we should always select the value which we want, that is VDS, right? The label which we want, that is VDS, right? So I'll select VDS. I'll start VDS from 0, and I will increment it up till maybe 6 volts, and I'll increment it with 0.5 volts or 0.1 volts. It's up to you. Okay, I'll increment it with the step size of 0.5 volts, or you can also take 0.1 volts. Okay, 0.1 volts. Okay. And talking about the source 2, so obviously in the drain source characteristic curve we will require VGS, right? So if VGS is less than VTH, then we need to check the graph. If VGS is greater than VTH, then also we need to check the graph, right? So in source 2 I will select VGS, and I will start value from 0. I will stop it maybe up till 5 volts, and I will increment it at around 0.5 volts. I will increment it by 0.5 volts. That is my step size. So over here I will select maybe I'll keep 0.5 volts only. It's fine for VDS. Okay, it's fine for VDS. I'll keep 0.5. Okay, then let me go to the output, and what we are going to plot. So basically we are going to plot the curve between IDS versus VDS, right? So as I mentioned over here, you don't directly add IVDS. Okay, why not IVGS? Because obviously we are going to plot the graph between IVDS versus VDS, right? That means the drain to source current, right? So that's why it is mentioned IVDS. So go in the add expression, click on add expression, then double click on absolute, and you make sure that your cursor is present in the bracket, right? Okay, and then select IVDS. Okay, something like this, as you can see over here. Okay, and then click on OK, and as you can see it is added over here, and then click on save, and then you can run this particular simulation. Alright, and as you can see this is the transfer characteristic which we had obtained. Alright, and you can clearly see over here this is 0 milliampere. Okay, my current is straight away 0 for which values, so you can clearly see over here. I don't know if this particular graph it is visible to you or not, or this particular part. So it's my request to you, please take a screenshot of it and then try to zoom out this particular image and then try to see it, or else I will write it for you all guys, don't worry about that. Okay, but you can clearly see over here when my VGS is 0 volts, so you can clearly see my IVDS that is over here. Actually the red color it is inserted in the purple one, so till purple, see over here when my VGS is 2 volts, see over here this particular point, when my VGS is 2 volt, my current is 0. See, I will uncheck this and you can clearly see I am getting this 1.5, that is blue color. I will again uncheck this. See, now my VGS is 1 volts, which is showing cyan color. Okay, I will again uncheck this. Now this is green color. When my VGS is 0.5 volts, I will again uncheck this, and you just see over here this time my VGS is 0 volts. So as you can see, when my VGS is 0 volts, so my current is straight away 0. I will again uncheck this, so you can clearly see the this particular curve is completely gone. Okay, it is completely vanished because I had unchecked all of these particular boxes. So let me again select it. So when my VGS is 0 volt, my current is 0. When my VGS is 0.5 volts, still my current is 0. When my VGS is 1 volt, still my current is 0. When my VGS is 1.5 volts, still my output current is 0, that is IVDS or IDS. When my VGS is 2 volt, still my output current or ID is 0. Okay, so let me just write over here for you all guys. Okay, because I can see it, but most of you all guys, you may not see it, but still for your understanding purpose. So see, this particular purple color curve, it indicates that my VGS is from 0 volts to 2 volts. So from 0 to 2 volts, my ID in this particular interval, my ID or IDS, whatever you want to say, it is straight away 0 milliampere or 0 ampere, right? So my ID or the output current is 0. Okay, in this particular curve. Now if you look over here, when my VGS is 2.5 volts, right? And we all know what is the threshold voltage for what is the threshold voltage for the MOSFET that we had selected, right? That is 2 and 7 000. So VTH, let me just write over here. So VTH, that is the threshold voltage for 2 and 7 000, 2 and 7 000. As I had already mentioned that you should remember this particular value as far as the plotting of this particular graph is concerned. It is how much? It is around 2.474, right? This is the value, okay, for the threshold voltage, right? And you can clearly see over here the VGS is 2.5 volts, right? VGS is 2.5 volts. That means this time my VGS is greater than VTH, right? So this is the curve that I'm talking about. See this white color curve, that I'm talking about. Let me erase it just a second and let me show it to you. I hope you understood this part. I will erase this one. Okay, that is the purple color line. As you can see, this is my, this particular line I'm getting when my VGS is in between 0 to 2 volts. Okay, so let me erase that since I had already explained you. Okay, now you just focus on this particular blue color box as I had mentioned over here. So let me uncheck it, and when I will uncheck it, so you can clearly see this white line will be vanished completely. Alright, so you can see the white line is getting vanished. Let me check it, or let me just tick mark on it. Okay, and you can clearly see this time we are getting certain value for the output current, that is the drain to source current. Okay, at 2.5 volts, that means when my VGS is 2.5 volts, I'm getting certain value for the output current, and this is because my gate to source or the input voltage, it is greater than VTH. And what is my VTH? It is 2.474, and my VGS is 2.5 volts, right? And that's why we are getting certain value for current. Okay, now let's suppose if I'm increasing my VGS from 2.5 volts to 3 volts, you can clearly see this is the curve that I'm getting, as you can see. Now let me uncheck it, and when I do this, when I uncheck this particular box, you will see that this kind of pink color line, it will be vanished. Alright, so you can clearly see the pink color line was vanished. Let me again tick on this particular box, and you can clearly see it is available over here. So this particular curve we are getting when my VGS is 3 volts. Okay, so let me erase all of the thing which I had written over here, and let me just write it for you all guys, so that you know it will be visible for you all guys. I'll write it with blue color only. Okay, so this is for when my VGS is in between 0 to 2 volts. Okay, because we had kept the interval of 0.5, right? If you could remember, in the simulate option during analysis and simulation, we had kept the increment value, if you could remember, of 0.5. So that's why if you see from 2, it is directly jumping to 2.5, right? And this white color curve we are getting when my VGS is how much? When my VGS is 2.5. This pink color curve we are getting when my VGS is 3 volts. This dark blue color we are getting when my VGS is 3.5. This is yellow color which we are getting when my VGS is around 4 volts. Sorry, it is around 4 volt. This we are getting when it is around, I guess, just a second. Yeah, 4.5. Yeah, it is correct. 4.5 volts, and this we are getting when it is around 5 volts, right? So we had kept an interval of VGS from 0 to 5 volts, right? And if you look over here, we had given the value of VDS from 0 to 6 volts, and you can clearly see my VDS, it is starting from 0 volts and it is ending at 6 volts, right? It is ending at 6 volts. Okay, great. So let me erase this. Okay, so you can clearly see over here that as my VGS is increasing, right? So my current ID also increases, right? And one more thing I can conclude over here is that you just note the points over here. So somewhere over here for this particular curve, this can be my VDS set or overdrive voltage, or I can also write it as pinch off voltage, right? For this particular curve, maybe this can be my VDS set. Okay, I'll just write over here only. For this particular curve, maybe this can be my VDS set, right? This can be my VDS set. For this particular curve, this can be my VDS set. For this particular curve, this point can be my VDS set, and for this particular curve, this point can be my VDS set. So as you can clearly see over here, as my VGS is increasing, right? Let me just plot it with some different color, so that it would be pretty easier for you all guys to comprehend this particular thing. Okay, something like this. I'm drawing it with my rough hand, so please try to understand it. Okay, so this particular curve, or whatever the region that is available before this particular white line, so all of this particular region, right? So all of this particular region, it is what? It is my linear region. It is my linear region, and whatever the region that is present after this particular curve, that means this particular region, this entire, sorry, let me erase it. Let me select some different color. Maybe I'll go with yellow. So this particular region, it is my saturation region. I know it is looking little rubbish, but I hope that you are able to understand this particular concept, right? Okay, so again I will repeat. So whatever the region that is present before this particular curve, or before this particular white line, or this particular white curve, that is my linear region. And whatever the area that is present after this particular white line, that is my saturation region. Great. I hope, or I believe, that you are able to understand these 2 points. Okay, so let me erase this, and I'll just discuss the last point. So maybe I'll select the red color region. Oops, sorry. Yeah, I'll select this particular red curve, and I'll click on the cursor. So you can clearly see over here, show cursor. So just click on it and just take this particular yellow cursor somewhere over here. As you can see, the values are changing, right? But we want this particular curve, or rather we want to see this particular curve. So for that, you see red color curve is it is able to it is able to see when my VGS is around 5 volts, right? So we are getting this particular red color curve, or red curve, when my VGS, or the input voltage, is of 5 volts, right? And you just see over here, or you just notice over here, yeah, so I'm talking about this particular values. That means when my VGS, as you can see, VGS is 5 volts, and you make sure that you are actually watching the y2. What is y2? Y2 is your current, the value of current, okay, that is available over here. So you just watch y2. So it's 1, 2, 3 and 4. So you just go on the fourth column. Okay, so just a second, let me go to the fourth column. Okay, 1, 2, 3 and 4. So it is, just a second, yeah, it is 436 milliampere. Okay, that means over here the value is 436 milliampere. All right, so let's start from maybe this particular point. So as you can see, the current is almost 0, right? 693 point something microampere. It is in microampere. I don't know if you are able to see it or not, but I will request you all guys to please plot this particular graph on the Multisim software with me, okay, so that you can actually see it, okay, practically. Okay, all right. So as you can see, when my current is 0, so it is showing me around 693 point something in microampere, right, which is almost 0 because my VDS is 0, as you can see. Now as I am increasing my VDS, so as you can see at this particular point, I am able to obtain certain current which is around 50 milliampere. You just watch over here, it is around 50 milliampere, and you can clearly see over here it is showing me 45.0819 milliampere. So it is very much closer to 50 milliampere, right? Now let me move this particular cursor somewhere over here. So this time I should get value somewhere around 70 milliampere, 70 to 80. Yeah, and as you can see, this time I'm getting the value of current to be around 86.69 milliampere, right? So as I'm increasing, maybe let's suppose if I'm stopping this particular cursor maybe at somewhere over here, so this time I should get the value to be around maybe 160 milliampere to be precise. Yeah, it's around 163.159 milliampere, right? Okay, so now let me shift this particular cursor maybe somewhere over here, and as you can see, this time I should get the value to be somewhat closer to maybe 370. Yeah, it's around 390 milliampere. Yeah, 390 milliampere. Okay, so as you can see, this is the value for current, this is the value for VDS, right? And let me shift the cursor somewhere over here, and you can clearly see it is this might be somewhere around maybe 416 milliampere, 420. Yeah, it's around 421 milliampere, as you can see. So what does that mean? That means if my VDS is increasing, my current is also increasing, right? This is what I wanted to show you. But let me just move my cursor forward. Let's see this particular point. At this particular point, I'm getting the value of current to be around around 450, 440, something like that. Yeah, it's around 436 milliampere, right? Now let me shift the point, or let me shift the cursor. Again, the value that I'm getting, it is around 441 milliampere. Let me shift the cursor. So as you can see, this time I'm getting the value of current to be around 447 milliampere. Let me shift the cursor somewhere over here. So this time I'm getting the value of current to be around 450 milliampere. Again, let me shift the cursor somewhere over here, and you can clearly see again the value is constant, that is 450 milliampere. Let me shift somewhere over here, and you can see the value is still 450 milliampere. And this is what I wanted to show you. That means what? After certain point, maybe after this particular point, maybe this particular point, yeah, maybe this one, yeah, 447. So after this particular point, see, after this particular point, the current ID is almost constant. And what is the value for it? So the value for current, it is around 450 milliampere, right? 450 point something. That is not a big concern for us. But let me move it somewhere over here. As you can see, till this particular point, maybe I'll select this one. Yeah, from here to all the way up till here, right? The value of current was increasing, right? The value of current was increasing as I was increasing the VDS, and my VGS was constant throughout, right? VGS was constant. That means my VGS was how much? My VGS was 5 volts, right? And this is what we had seen in the drain source characteristic, right? But the most important point to notice over here is that this is my linear region, right? And this is my saturation region, okay? Saturation region. And thus we had concluded that after certain point, so this particular point, that is VDS sat. So let me change the color. So this point is known as VDS sat, saturation, VDS sat, or pinch off voltage. And what is that particular voltage? So this voltage would be around maybe 3.3, 3.2, something like that. Let me see. For that you have to yeah, see this value, that is x2. You have to see x2, which is 1, 2, 3 at the third column. So let me go over here. Yeah, when my VGS is 5 volts, as you can see, it is around 3.37, right? So this particular value, it is 3.37. So this particular value, it is 3.3727, right? As you can see, 3.3727, right? So this particular value, it is my pinch off voltage. It is my pinch off voltage, or VDS saturation voltage. Okay. So I really hope that you understood the drain source characteristic. You also understood that how exactly we are plotting it on the Multisim software. Okay. And you also understood the concept of VDS sat, or the pinch off voltage, which we had discussed during the working of N-channel MOSFET. Okay. So I hope you really understood each and every concept that we had discussed till now. Okay. But still, if you have any doubts, if you are facing any difficulties anywhere, even in the simulation, you please ask me. You please make sure to ask me in the communication section. I will make sure to clear all of your doubts. It can be any doubts, it's fine. But the most important thing that is, you should ask me the doubts, right? Okay. So I am ending this video over here. Okay. So thank you for listening patiently.